Math Day? Great day, Math Lead learners! Welcome to the Mathematics Lead channel, where we turn your math worries into mastery. I am Ma'am Ashley, and together, let us have fun while learning. Today, we are going to tackle solving problems involving polynomial functions. But before all, let's go to our learning objectives. First, here, at the end of the lesson, students should be able to, let's read together, A. Identify and understand different types of polynomial functions according to their degree in word problems. B. Evaluate polynomial functions using the problem-solving strategy. And C. Appreciate the role of problem-solving involving polynomial functions by having reflections on real-life encounters. So, are you guys ready? Okay, let's now proceed to our engaging activity so that your minds will be refreshed and motivated to learn. The title of our activity is "The look seems familiar." What is it? Here's our instructions. I will show pictures that represent or do not represent the graph of polynomial functions. And you guys will then determine the functions by writing in your notebooks or papers the correct answer, wherein, if it's a function, you will write yes name. If it's not a function, write no name. Okay? Let's go to the first picture. Okay, do I look like a familiar function? Let's see. I'll give you guys 5 seconds to answer. In 5, 4, 3, 2, and 1. Okay, time's up. I hope that everyone got an answer for this. So let's see. Oh yes, it's yes name. It is a function. So can anyone recall what kind of function is this? Okay. Oh yes, indeed. It is a linear function. Specifically, a linear function of y is equals to x minus 2. Okay, very good, everyone. Okay, let's proceed to the next picture. Do I look like a familiar function? I'll give you guys 5 seconds again to think. Okay, in 5, 4, 3, 2, 1. Okay, time is up. Okay, let's see if it is a function. It says no, ma'am. Okay, let's see why. Because it is a circular function, and it fails to satisfy the vertical line test that determine the graph's functionality. Okay, I hope that everyone got the correct answer, and all of you still did a great job. I hope that this activity helped you remember a past lesson on graphing polynomial functions, because it is crucial for our topic today. Since you guys are now ready, let's formally activate our knowledge by discussing the different types of polynomial functions and their real-life applications. Okay, for our first type of polynomial function, the constant polynomial function. When we say constant, it remains unchanged. And here we have the general form of f of x is equals to a. The a is the constant. And here, it says that it models a situation with no change. For example, we have here the graph of no change in position. As you can see here, there is no change in the object's displacement over time. Therefore, our function is constant. Okay? I repeat, constant means unchanged. There is no change in the subject. Yes, alright. Okay, let's proceed. Next is the linear polynomial function, wherein the degree is 1, the highest degree is 1. And here we had a general form of f of x is equals to ax plus b. And it is used for the constant rate of change, commonly used for constant growth or decay. Here, we have the graph of car value and how this value decreases over time. From what we can see, the values are constantly decreasing and they form a diagonal line, indicating that it is linear. When we say linear polynomial function, it determines the decrease or increase, the growth or decay. Okay, again, the linear polynomial function, what we can see from the graph is the diagonal lines. Okay, and remember, it has a degree of the highest degree of 1 in the x variable, which is why we have ax plus b. Okay, the next type is a quadratic polynomial function, wherein the highest degree is 2. And here we have the general form of f of x is equals to ax squared plus bx plus c. Here the highest degree of x or exponent is 2. And it says that it indicates the peak of the trajectory or the maximum and the lowest possible value, or the minimum. Here we have another example, wherein a person is throwing an object that goes in a curved path, forming a downward trajectory or a parabola that opens downward. And here, when we form a parabola, it can be determined as a quadratic polynomial function, which has, again, the highest degree of 2 when we say it's quadratic. Okay, let's proceed to the next. It is the cubic polynomial function. What can you recall about cubic function? When we say cubic, it has a 4 volume because it has the highest degree of 3. Yes, that's right. Which why we have the general form of f of x is equals to ax cubed plus bx squared plus cx plus d, wherein a is not equal to 0. And it's used for indicating the dimension of complex changes in objects having an S-shaped curve. Like the example, this function forms an S shape as the representation of its complexity. And here, the path or dimensions of the roller coaster can be measured in R as a cubic polynomial function. Okay? Again, as cubic for 3, quadratic for 2, and for 1, linear, and for the 0 degree or the constant only, the constant polynomial function. Okay? Now, since you already know about the different functions, let's apply it to problem solving. Okay? We have here the example number 1. The clown has been selling balloons for only 50 pesos since the park's opening. The first thing that we're going to do is to understand the problem. Wherein, we have the given of balloon prices, which is equals to 50 pesos. Next, we're going to think and strategize for the plan or the formula that we're going to use, which in this case, as you can see in the question, it is mentioned in the question the word since, which means that the price doesn't change since the park's opening. When we says no change, it means, again, yes, constant polynomial function. Since we now know the function that we're going to use, we're going to implement the plan, in which we can determine the value of the function by substituting the given values into the formula, wherein it is easy in this part because we're going to use the constant polynomial function, which means we're going to just substitute 50 to the constant a, where we have f of x is equals to a and f of x is equals to 50 through substitution. And now we arrive at an answer of 50 pesos. If we graph it, we are going to form a horizontal line proving that it is a constant polynomial function. Okay, I hope that everyone get it. Let's proceed to our next example. Our example number 2, let's read everyone. The price of a ticket for each ride on a carousel amounts to 50 pesos for kids and 70 pesos for adults. If Janice, a kid, rode a carousel 3 times and her mother accompanied her on her first ride, how much did she spend on a carousel ride? Okay? Again, let's first understand the problem by knowing the given. Here, we have the given of the price of the ticket, 50 pesos for kids, 70 pesos for adults. And the times they rode, Janice rode it 3 times and her mother rode it for 1 time only. Let's strategize and analyze the question. And here, as you can see, we have the kids' ticket price and the adults' ticket price, which means we have 2 constant and we have the number of times Janice rode the carousel, which we can say that it refers to the x. Therefore, we're going to form a function which has a, x, and b, and as we look back, it is a linear function wherein f of x is equals to ax plus b. Okay, let's go to implementation of the plan, where we have f of x is equals to ax plus b, wherein our x again is equals to 3, the number of times Janice rode a carousel, and a as 50, the ticket price for kids, and 70, the ticket price for adult, wherein we have f of 3 is equals to 50 times the quantity of 3 plus 70. Okay? When we multiply or perform the operation, we're going to have 150 plus 70, where we get the answer f of t is equals to 220, which means that Janice and her mother spent 220 pesos on carousel ride. Okay? Did you guys get it? Okay. Clap for everyone if you guys get it. Okay. Oh my god. Let's proceed to the reflection, which in here we can see that the graph forms a linear function, which proves that it is a linear polynomial function as it forms a diagonal upwards. And here we can see the point of f of x is equals to 50x plus 70 in the point of t and 220. Okay. Here, let's proceed to example number 3. Okay, everyone read. 300 people want to enter at the amusement park when they found out that the ticket price is 200 pesos. Accordingly, for every 10 peso increase in the price, the number of people decreased by 15. So, how much is the maximum revenue for a 30 peso increase? Let's first understand the problem again. We have here the given. There are so many given here, so don't be lost in the minutes. Okay, I'm just kidding. Let's proceed. We have here ticket price is equals to 200 and the ticket price increase that is equals to 10. And we have here the number of people wherein they say that there are 300 people who want to enter the amusement park. And the number of people's decrease every time the price increase is equals to 15. And here we have the increase of 30 pesos that happened, that we have to get the maximum revenue. So, how are we going to manipulate this problem? We have to understand that the ticket price must be equal to 200 plus 10x, wherein 200 is equals to the ticket price, original ticket price. The 10x is the 10 peso increase in the price. X because we're still going to analyze what is x on how many times that the price increase. Okay, the number of people is equals to 300 minus 15x. The minus 15x or the negative 15x refers to the decrease of people. And here we have the increase that equals to 30, which means this 30 pesos increase will be the basis of how many times the increase happened. And if we divide 30 by 10, the 10 peso increase, we will get the quantity of 3, wherein this will be our x. The x is equals to 3. Okay, so how are we going to manipulate this? We're going to compute for the maximum revenue by multiplying the ticket price to the number of people. Okay, so we have here the f of x times the ticket price is equals to ticket price times the number of people. And f of t is equals to the quantity of 200 plus 10x times the quantity of 300 minus 15x. And as you can see, when we recall from our past sessions, we're going to apply the FOIL method, the first, outer, inner, last term method, wherein we're going to times the first one first. 200 times 300 is equals to 60,000. Then the outer terms, 200 times the negative 15x is equals to negative 3,000x plus the inner term, which is 10x times 300. So we have 3,000x. Then the last term, 10x times negative 15x. We have negative 150x squared because we multiply two variables, x times x. We're going to add their exponent. We have invisible 1 and invisible 1. We have x squared. Okay? Is that good? Okay, let's proceed. We're going to rearrange this in the general form. So we're going to have f of 3 is equals to negative 150x squared plus 0x. As we can see, it's both 3,000x. So we're just going to cancel it and we're going to have 0x and the 60,000 as a constant. Okay, let's implement the formula. Again, we have the general form of f of x is equal to ax squared plus bx plus c, which is a quadratic polynomial function. And f of t is equals to negative 150x squared plus 0x plus 60,000. We're going to just substitute t to the x, which is we're going to have negative 150 times the quantity of 3 raised to 2 plus 0 times 3 plus 60,000. Okay, we're going to square the 3. So we're going to have 9. And so negative 150 times 9 plus 0, because 0 times 3 is 0, and plus 60,000, we're going to have an answer of 58,650. So it says that the maximum revenue of the amusement park for a 30 peso increase is equivalent to 58,650 pesos. And here we can see the graph that says it forms a parabolic graph, wherein when we say parabola again, when it forms a trajectory, it is indeed a quadratic polynomial function, which proves that our formula is correct. Okay? So that is our last example. I'm going to leave you guys to develop the competencies and activity or a practice activity that you guys can access and answer anytime at your own pace. So here it is, the quiz is link, so you can type this or screenshot this to get the QR. And I hope that you guys learn a lot from today. So that's all. Thank you for listening, and I hope that you had a good day and good learning for today. So goodbye and see you again for the next video.